In Chapter 8.1, we learned how to graph a system of equations. In Chapter 8.2, we learned the addition system for solving a system of equations. Now in Chapter 8.3, we're going to use the substitution method for solving a system of equations. I'm going to put three examples up here that are on page number 603. Number 4, number 12, and number 26. And as you can see, they get more and more complicated, but this is really not all that difficult. What I also want you to note is if you look down at the bottom of page 603, it says for problems 29 through 36, solve each system by using either the addition system or the substitution method, and a unique solution does not exist, and so forth. So what they're doing is they're giving you tools to work with. Graphing they won't use so much anymore because these don't require to use the graph paper, and if you find one system works better than the other, go ahead and use it. You have more tools at your disposal. Anyhow, looking at number 4, when we take a look at our second equation, what we have is y equals negative 4x. So already for y we have a value. Now what we'll do is go back into that first equation, which is 4x minus 3y equals 24. And instead of y, we'll substitute in that solution. So it's 4x minus 3 times the quantity negative 4x equals 24. Now when we do that, we get 4x plus 12x equals 24. And now we don't have any y's anymore. All we have is x's. So 4 plus 12 gives me 16x equals 24. And then 16x over 16 equals 24 over 16. So therefore x equals, and when we reduce 24 over 16 down, we realize that 8 divides evenly into both, and that gives us 3 over 2, or 1.5. Now, the final part of that solution is, now that we know what x is equal to, we can go back to either equation. I like to go to the simpler one, which is y equals negative 4x. And I get y equals negative 4 over 1 times x, which is 3 over 2. These cancel. This becomes negative 2, and y equals negative 6. So there you have your two solutions for number 4, and they are x, which is 3 over 2, and y, which is negative 6. And what they're expecting is that's the way you're going to write your answer, in that format. All right, so we've got that first one out of the way, and what I wanted you to note, and the reason I picked number 4 is not always are the answers whole numbers. But hopefully from now on, as we get more complex problems, we'll get answers that are whole numbers. And that's the reason I picked the problems that I did. Let's go ahead now and take a look at number 12. In number 12, what we have is we have a value for y, but now y equals negative 5x plus 4. We're going to go ahead and substitute that into that other formula. 4x minus a negative 5x plus 4 equals 14. Now all we have to do is that distributive property multiplying through by negative 1. So negative times a negative 5, that makes it a plus 5x. And minus 4 equals 14. Combining like terms, we get 9x minus 4 equals 14. Now we add 4 to both sides, and we get 9x equals 18. Then 9x over 9 equals 18 over 9, and x equals 2. Now we can substitute that x into either formula. This time I think I'm going to substitute it into the first one. you could have chosen to do the second one if you wanted. 4x minus y equals 14. I'm substituting 2 in there for the x, so 4 times 2 minus y equals 14. 8 minus y equals 14. Subtracting 8 from both sides, what I get is minus y equals 6. But I can't have it a negative y, so I have to change that, dividing both sides by negative 1. That makes this a positive y, and that a negative 6. So my solution here is 2, negative 6. Now, that's not that much harder than number 4 was. But when we take a look at number 26, now we've got something a little different, because we have two linear equations where we have x and y on the left-hand side of both equations. I'm erasing this because I need more space in solving number 26. What I'm going to do now is I'm going to take one of those and come up with a value either x or y equals something. While I'm looking at those two, what I notice is in that second equation, x minus 2y equals 5, I've got that x all by itself right here. So that's my focus. I'm going to take that equation, x minus 2y equals 5. And what I'm going to do to isolate that x is add 2y to both sides. What I get now is x equals, and I'll put it as 2y plus 5. If you wanted to put it as 5 plus 2y, that would be okay. But typically they put the variable first. Now when we go back to our other equation, 5x minus 6y equals 21. We can substitute in for x 5 times 2y plus 5 minus 6y equals 21. Distributing, we get 10y plus 25 minus 6y equals 21. When we combine the like terms, which happen to be the 10y and the negative 6y, we'll get 4y plus 25 equals 21. Now what we have to do is subtract 25 from both sides, and we'll get 4y equals negative 4. And then dividing both sides by 4, we'll get y equals negative 1. All right? Now what we need to do is we need to find the value for x. We can go back into either one of those formulas, but now to me that second one looks simpler than the first. That's the x minus 2y equals 5. And I like to follow what I call the KISS principle. I don't know if I've mentioned that to you before, but KISS means keep it simple, stupid. So I go for that second equation over the first one because it looks simpler. You can use either one, but if we do that, then we put x minus 2 times minus 1 equals 5. This now comes out to be x plus 2 equals 5. Subtracting 2 from both sides, we end up with x equals 3. Now that was a little simpler than probably using the other one. Our answer, however, is our xy coordinates. X is 3, y is negative 1. So what we've done now is we've solved 3 of these problems. Those should be 3 really good examples for you. What we want to do next is we want to turn over to page 604 and take a look at some story problems. Again, like the previous chapter, all we're going to do is set these up. And in solving these now, you may use either the addition method or you may use the substitution method. But let's take a look at number 46. And number 46 it says the difference of two numbers is 4. So I let x equal the first number, and I let y equal the second number. The difference between those two, difference means subtract, the difference of the two numbers is 4. If I say x minus y equals 4, then my assumption is x is the larger number. It also says the larger number is 8 less than twice the smaller number. The larger number, x, equals 8 less than twice. And sometimes people think, well, I'd write 8 minus 2x, but 8 less than, when we talk about those phrases, what that means really is 2y minus 8. All right? So now you have your two equations, and this one looks like you could use either approach. Either one of those should work pretty well. So let's jump down and take a look at number 50. In number 50, what we have is a washer-dryer combination costs $1,200. Well, right then and there, you know that this isn't a realistic problem because washers alone cost like $800 to $1,200. But for our purposes, we're going to let x equal the washer, and therefore y equals the dryer. That combination costs $1,200. So x plus y equals $1,200. The next statement says if the washer costs $220 more than the dryer. So if the washer is equal to the dryer, which is y, but it costs $220 more, it's going to be y plus 220 because that washer is more expensive. Now you've got two formulas, you can go ahead and go for it. That looks like a pretty simple one. I think I'd take that second formula, subtract x on both sides, and now I would get x minus y equals 220 and go from there. That should work pretty well. All right. Now, in number 58 is a geometry. It says the length of a rectangle is 5 centimeters more than 3 times the width. So what I'm going to do is I'm going to let x equal the length. You could let x equal the width, but I'll let y equal the width. Okay? I've got my rectangle. My length is x and my width is y. Okay, so it says the length of a rectangle is 5 centimeters more than 3 times the width. The length x equals 5 centimeters more than 3 times the width. 3 times the width plus 5 centimeters. I'll take that label out there because it would only confuse things, but we know it's 5 centimeters. So in our answer, we're going to have answers with the label being centimeters. Now it says if the perimeter of the rectangle is 74 centimeters, find the dimensions. With rectangle, what we need to remember is the perimeter is 2L plus 2W. In this particular case, our perimeter, which they say is 74 centimeters, is equal to 2 times the length. And I said our length was 2 times x, plus 2 times our width, and our width happened to be y. Now we have, oops, I'm sorry, forgot to put the little 2 in there. Let's erase that. It's 2 times y. Now we have our two formulas. This one looks like it lends itself to the substitution method because over here in this first formula we have x equals 3y plus 5. All right, I want to take a look at one more problem, so I'm going to have to erase here a little bit. We're going to take a look at the top of page 605 at problem number 60. In problem number 60, a business and finance thing, it said the cost of an order of 10 computer disks and 3 packages of paper is $22.50. All right, so for number 60, we'll have to let x equal something. We'll let it equal the computer disks. Therefore, y is equal to paper. We could put packages of paper. I'm just saving us a little bit of time. The cost of an order of 10 computer disks, 10x, and plus 3 packages of paper, 3y, happens to be $22.50. In our second part, what it says is the next order for 30 disks and 5 packages of paper was $53.50. So our other one is 30 computer disks plus 5 packages of paper, 5y, equals $53.50. Now, these being in that format, I think I'd look at the addition thing, and I'd put this second formula, 30x plus 5y equals 53.50. And in order to balance these out, I think I'd take that first one and multiply it through by -3. Because what that would give me, once I did the multiplication, I'm going to remove this over here, would give me minus 30x minus 9y equals minus 67.50. And of course we have a 30x plus 5y, and that equals 53.50. So when we combine those, we'd have a negative 4y equals a negative 14. So from that point on, you can go ahead and figure those out. And I don't think that these story problems will give you too much trouble.